Okay, so here's problem 7.5.49. Question was asked over email, and they're giving us a table that lists data regarding the average salaries of several athletes in the years 1991 and 2001, and they want us to use the data points to find a linear function that fits the data, and then use the function to predict the average salary in 2005 and in 2010. In this first part here, they ask us a linear function that fits the data is s of x equals, so we need to find the function. And then the second thing that they do is they actually tell us how to define our variables here. They tell us to let x be the number of years since 1990, and then s be the average salary x years from 1990. And then this is the chart that they're giving us right here. Okay? So if we just take a look at this, they're giving us a couple of years and they're giving us a couple of salaries here. And they're defining for us, they're saying let's let x be the number of years since 1990. Okay? And if that's the case, then this is our x and this is our s of x. So we're looking at ordered pairs here that are going to be s and s of x. In other words, x, y, but the y here is s of x. Okay? And I'm just going to use y until we get to the end, and then I'll replace our y with s of x. Okay, so we actually have two ordered pairs here. We have the ordered pair 1991, and then 272,000, and then 2001 and 1,480,000. But they have asked us to define the number of years, x to be the number of years since 1990. So this would actually be a situation when I have x equals 1. So the first ordered pair here would be 1 and then 272,000. Okay. The second ordered pair here since 1990, this is going to be year 11. So in year 11, we're dealing with a salary of 1,480,000. Okay, so now that I have two ordered pairs, I can find, I'm going to want to find the equation of the line. It's going to be a two-step process. So I'm going to, first of all, have to find the slope, and then I'm going to have to use the point-slope equation to find the equation. Okay, so I'm going to label this x1, y1, and I'm going to label this x2, y2. And when I plug it into my slope formula, and remember that your slope formula is this, y2 minus y1 over x2 minus x1, this becomes y2, which is our 1,480,000 number, and this is minus y1, which is 272,000. These are both dollar amounts in the top. Okay. In the bottom here, I'm going to have x2, which is 11, minus x1, which is 1. Okay, and these are years. Okay, so our slope here ends up being I'm going to take my 1,480,000 number, subtract the 272. So I get this in the top. So 1,208,000. And this is over 11 minus 1 in the bottom, which is going to be 10. Okay? And then if I just divide these two, it'll essentially knock off 1 0 here. So I'm going to have 1, 2, 0, 8, and then 0, 0. Okay, so now this is dollars, and this is per year, because this was our year unit in the bottom. So if we were thinking of this slope as a rate of change, the fact that it's positive tells us that we're increasing over time, and we're increasing at a rate of 120,800 per year in terms of their average salary. Okay? All right, so that's the first step. The second step is we want to use our point-slope equation, which is this, in order to find the equation of the line. Okay, so I'm going to just use the the slope that I found, which is that slope right there. And I'm going to go ahead and use just this ordered pair, since we already have that labeled as x1, y1. Okay, so we're looking at plugging in a slope of 120,800. Okay. Thanks. And so a slope of 120,800, and our x1, y1 point was 1 and 272. Okay. All right, so if we plug those in, then we get y minus y1 equaling our slope times x minus x1, which is just 1. And we do want to solve this for y, so I'm going to need to take this 120,800 and distribute it. So it's going to look like y minus 272 equaling 120,800x, and then minus 120,800 when I multiply that by the 1. Okay, so to isolate y here, I'm going to add the 272 to the other side. Okay, and I get y equal to 120,800x, and then this is going to be, let's see here, 272 minus 120. So I get a positive 151, 200. Okay. All right, now they did ask us to define this in terms of x and s of x. So our function here would be this one right here. So that's what they want in that first part here. In this first part of the problem where they're saying a linear function that fits the data is, that's what they want in that box. Okay, and then in these next two boxes, what they want is in 2005 and in 2010, they want us to predict the average salary. Okay, so essentially what we're going to be doing is plugging in a value here for both the 2005 and the 2010, and then finding out what goes with them. Okay, so so in 2005, that would be 15 years after 1990. So this would be x equals 15 in 2005. Because remember that we had x defined to be the number of years since 1990. So in 2005, we're at x equals 15. If I evaluate that, just plug 15 in for my x and do the math. I'm going to get this number right here, 1,963,200. I wouldn't mind making that much money per year. Okay, and then in 2010, that's going to be, if we take a look at, remember how it's defined, number of years since 1990. So 2010 is 20 years beyond 1990. So I am evaluating s at 20. So that is, again, plugging it into my function. Right here, everywhere there's an x, I'm going to plug in 20. So it becomes these big numbers times 20. Okay. So when I multiply by 20 here, multiply by 20 first, and then add your 151, 200, and I get 2,567,200 for year 20, for year 2010.